Okay, we start with our validation, and before go with the validation, I'm just gonna mention how it works. We wanted to show that our program works as intended purpose. You see this piece is put on a certain angle. We're gonna check what it is with this level. Okay, you see this angle shows exactly what angle we are in, and this validation piece is a thin cardboard, 100 millimeter to 300 millimeter. We put a line at the middle so we can check the angle. As we can see roughly 29.7 degree, 29.8. And now we're gonna check where our camera exactly by means of angle is like 0. So if the camera is 0, that means when the camera take a picture of this validation part, it's supposed to get exactly to 9.7. So we have a program here, works on principal component analysis. This program takes a picture of the image, calculates the angle of the object, and then sends this object angle to servos. Servos goes to the absolute angle, and then we have a little robot arm here. Then that robot arm will move to that angle. Now I'm gonna start the program, and in a short time, less than a second, it's gonna make the calculations, and in a real short time you will see the robot arm will go with that angle. Okay, our calculated angle is 29.2. Of course, the calculations comes with some errors, maybe, or measurement error, systematic error, lights, and a bunch of factors affecting the program calculations. And if you already saw that the robot arm went to that angle pretty much a short time period. Actually, I can also see the calculation time here is 0.7 seconds, and the robot arms moves like maybe half a second. Anyway, so this is not going to be exact measurement. We know that servo automatically goes to absolute angles. But like just to show, like a, roughly, you see, roughly we are around like 29 degree. Of course, this is not a absolute validation where the robot arm is, but it's close enough, as you might see. Okay, since we are done with our validation, I'm gonna move the next step of our presentation. I'm gonna put our program in a continuous boot, and you will see the robot arm will continuously move to the angles, but this time I'm gonna use myself as a master of motion. I'm gonna put my arm, and I'm gonna move my arm, and you will see the robot arm will follow continuously. But we will have some delays because our version of the program only can take 2 frames per second roughly, and with some delays gonna occur, and then we will see the program will follow eventually where my arm is, but it's gonna come a little bit a few frames after. I think the program is ready to run right now. I'm just starting. So you will see it started to move, and it's going up, and now it's gonna go down. See, it's going down, and it's actually pretty much acceptable speed, and you will see it's gonna go up again. and now it's going to go down. As you see, eventually robot arms follows and performs as intended.